Hello everyone, today I want to explain my homework 3, homework 1. I will explain a pneumatic system and its electronic pneumatic single floor diagram. The system follows the motion sequence A plus A reduce, B plus B reduce, C plus C reduce with a cascade control system. Let's start with the basic. First, let's look at the key parts of the pneumatic system. They are divided into three main types. Actors. These are cylinder A, B, and C. Their job is to make cylinder back and forth movements. You can think of them as the workers that do the actual moving in the system. Control components. These are double cylinders direction levers marked Y1 to Y6. They control whether the air circuit is open or closed. This control helps the cylinder change their moving direction. Detraction compass. These are proskim switches like A0 or A1, B0 or B1, C0 or C1. They check where the cylinder are. When the cylinder reaches the right position, the switch is set back a down-moving signal. Now let's see how the cylinder levers make the cylinder move. Each lever controls one type of movement for a cylinder. When Y1 gets power, cylinder A stretches out. We call this A plus. When Y2 gets power, cylinder A pulls back is A reduce. When Y3 gets power, cylinder B stretches out is B plus. When Y4 gets power, cylinder B pulls back is B reduced. When Y5 gets power, cylinder C strains out is C plus. When Y6 gets power, cylinder C pulls back C reduced. It's like each lever is a switch that tells a cylinder to go out or come back. The system has a fixed order of movements, split into three patterns. First one. First, cylinder A stretches out A plus. After it's done, cylinder A pulls back A reduce. 2. Only when A finishes its movements, cylinder B starts. It stretch out B plus first, then pull back B reduce. When B is done, cylinder C begins. It stretch out C plus and then pull back is C reduce. This order is very important. One cylinder can't start until the previous one is finished. To make the system work, we need an electronic control circuit. Its main parts are first, power supply. It provides 24 volt and 0 volt electronic. This is like the battery for the whole circuit. Logical components. These are intermediate relay K1 and K2. They make singles stronger and change logical, like turning a start single into a more single for viewers. Actors, these are the cylinder vehicles Y1 to Y6. They get electric signals from the circuit and then conquer the air floor for the cylinders. Let's talk about how we control cylinder A plus and A reduce. Start single. There is a button called ST. Pressing it start the whole system. This is the first push for AS movement. Feedback singles. Proximate switches B1 and A1 help. They tell the system when A should stop strange and start pulling back. Relay rail. When relay K1 gets power, its contact like small switches inside move. This makes wave Y1 for A plus or Y2 for A reduced get power, and then A moves. Next is the control logical for cylinder B plus, and B reduced. Finger premise B can only start when cylinder A is in the right position. The approximating switch A1 sets a signal to say A is down. That's when B can start. Feedback signal. Approximating switch C1 works here. It tells B when to stop stranger and start pulling back. Relay through. When relay K2 gets power, its contacts move. This makes viewers Y3 for B plus or Y4 for B reduced get power, and then B moves. Now the control logic for cylinder C plus, and C reduce. Finger promise C can only start when cylinder B is in the right position. Approximating switch B1 sets a B is down signal, then C starts. Direct control. Unlike A and B, C doesn't need actual relays. The contacts of relays K1 and K2 work together directly. They make viewers Y5 for C plus or Y6 for C reduced. Get power and then C moves. What is cascade control actually? Definition. The signal from the last part, like the approximating switch of the previous cylinder, becomes the start. Signal for the next part. This makes the cylinder move one after another, depending on each other. Since it's all about feedback of finished actions, we use this feedback signals to make sure the cylinders move in order, no jumping ahead. That's how we get the A to B to C sequence. Let's break down the cascade flow step by step to see how it works. From A to B, when cylinder A reaches its right position, approximating switch A1 sets an A1 signal. This signal makes relay K2 get power. Then K2 contact mode and B start stretch out B class from B to C when cylinder B reaches its right position. Proximity switch B1 sets a B1 single. This single makes Wi-Fi get power directly, then C start stretch out is C+. Each step is linked. A is finished, start B. B finished, start C. We used a real-time model to check if the system works. First, let's look at cylinder A stretch out A plus operation. We started the model and watched the link. Press ST button. Relay K1 gets power, wave Y1 gets power. Cylinder A stretch out A plus. Reflection, we checked when proximity switch A1 was triggered. It only set a single when A was fully stretched. This shows A plus works correctly. Next, we checked the cascade from A pulling back A reduce to B stretch out B plus. Operation, we watched the link A1 single A is down to relay K2 gets power, wave Y3 gets power, cylinder B, stretch out B plus. Reflection, right after A finished pulling back, B started stretch. This is actually the cascade logical we need. It works. Finally, we can check the cascade from B pulling back B reduced to C stretch out C plus and then pulling back C reduce. Operation, we watched the link B1 single B is down to value Y5 gets power, cylinder C stretch out C plus after C is stretched. Wave Y6 get power, C pulls back C reduce. Reflection when B finished pulling back, C started moving right away. Then C stretched and pulled back smoothly. This shows the whole cascade process works perfectly. Let's wrap up with the key point. Single field overview. The complete path of single is start A plus to A reduce, B plus, B reduce, C plus, C reduce. Every step follows the order. Thanks for cascade control. Key knowledge point. After this exercise, I know what its pneumatic competence does and know how to design the electric control logic and the principle of cascade control. And I want to show you this. Okay, this is my answer. Thanks for your listening.